Okay, so today we're going to talk about, continue on with 1.2, talking about distance, and then in 1.3 we talk about the midpoint of segments, okay? One thing that I want to mention to you is congruency of segments. Two segments are said to be congruent if they have the same measure. And notice they'll put this little line right here, that pink or red line right there to show that they are the same measure. So and here's how they would explain that. Segment AB, using my symbol, is congruent to segment CD. That's how I would write that, okay? And looking at the distance formula now, the distance on a coordinate plane would be the absolute value of one point minus the other. And it doesn't matter if I say x1 minus x2 or x2 minus x1. Okay, so if we go ahead and look at our first example right here, use the number line to find AX. So AX is the length, the distance between these 2 points. If I had the absolute value of x2 minus x1, then that would give me the absolute value of 3 minus negative 5. And remember, 2 negatives make a positive, so that would give me the absolute value of 8. So AX would be equal to 8 units. All right? So that's what it would look like on the number line, okay? The distance formula on a coordinate plane, okay? Notice here you've got an x and a y. So here our distance formula would be the square root of my x values squared plus the difference between my y values squared. So this is our distance formula. They use PQ right here because PQ is the segment that they're talking about. All right, let's go ahead and move on to example 2. In example 2, it says find the distance between E, which is negative 4, 0, and F, which is 3, negative 1. So if I scoot this down just a little bit here, F, we have 3, 0, negative, E would be negative 4, 0. 1, 2, 3, 4, stay there, okay? And F would be 3, down 1. So this is our segment right here, okay? So we're looking for the distance between these 2 points. Now, whether you look at it graphed or if you look at it listed right here, since E was our first point here, we could call it x1 and y1, and F would be x2, y2. So remember, the distance between EF, using our distance formula, would be the square root of my x values, 3, minus negative 4 squared, plus the difference between my y values, negative 1 minus 0 squared. 2 negatives make a positive. We had the square root of 3 plus 4, which is 7 squared, plus negative 1 minus 0 would be negative 1 squared. We would have the square root of 49 plus 1, which would be the square root of 50. And you can leave it like that, okay? So that would be the length of EF. And if you wanted to, you could give it to me as a decimal as well, okay? All right, moving on. Now we're going to talk about the midpoint formula, okay? Midpoint on a segment on a number line would be the addition of these two divided by 2 would be the midpoint on a number line. So if we now look at this example again and say use the number line to find the midpoint of AX, then we would have AX is equal to x1 plus x2 divided by 2. Okay, so that would give us negative 5 plus 3 divided by 2, and negative 5 plus 3 would give us negative 2 divided by 2, so AX would be equal to 1. So right here at 1 would be our midpoint. Okay? All right, let's move on. Our midpoint formula in a plane, you have, now notice you've got x and y coordinates, so both of them, okay? Not only do you have to figure out where the midpoint is on the x value, but also in their y value. So here's our midpoint formula. So example 4 says find the coordinates of M, the midpoint of GH, where G is 8, negative 6, and H is negative 14, 12. All right, so I'm going to go ahead and draw this so I have a good idea of what it looks like, okay? So G is 8, negative 6. M M is the midpoint of it, and then H is located at negative 1412, okay? So again, judging by my midpoint formula, it's equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, all right? Again, it doesn't matter which one you label as your first point or your second point, x1, y1, x2, y2. All right, so that would give us 8 plus negative 14 divided by 2, comma, negative 6 plus 12 divided by 2. So 8 plus negative 14 is negative 6 divided by 2 is negative 3, and negative 6 plus 12 is a positive 6 divided by 2 is positive 3. So that's where M would be located, okay, in your coordinate plane. All right. Our next example says find the coordinates of D if E is the midpoint, okay? If E is the midpoint of DF, and E is located at negative 6, comma 4, and F is located at negative 5, comma negative 3. Okay, now we're going to look for D. Obviously, D is not the midpoint, but I am going to give it a point, x1, y1. It is the first point in our segment here. So remember, E is the midpoint, okay? So when you have M is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2, M is what we're going to put in place over here. So negative 6, comma 4 is equal to my x1, I don't have a value for it, plus my x2, remember, is negative 5 divided by 2, comma, y1 plus negative 3 divided by 2. So here I want you to keep in mind that this negative 6 is the x value of my midpoint. So I could say negative 6 is equal to, because remember it's equal to, the x value of your endpoint, x1 plus negative 5 divided by 2. Same thing for my y. 4 is equal to the y value of my endpoints, y1 plus negative 3 divided by 2, okay? So the first thing I'm going to do algebraically to solve is multiply both sides by 2, all right, to get rid of the dividing by 2 over here. I have negative 12 is equal to x minus 5 plus 5, negative 7 is equal to x. Again, over here, multiply both sides by 2. And I get 8 is equal to y minus 3 plus 3 plus 3, 11 is equal to y. So D would be located at the point negative 7, comma 11, and now we are done. Okay? Notice the difference whenever we actually have it, the midpoint formula. Okay? Last thing. What is the measure of PR if Q is the midpoint of this segment? Okay, if Q is the midpoint, remember then these two segments are going to be congruent. Okay, so I'm going to use my marks there. So whatever this measure is, this one's the same. So that would be also 6 minus 3x. I've got PR as 14x plus 2. So if I'm looking for the actual measure of PR, remember what we did last time. PQ plus QR equals PR. So if I plug in 6 minus 3x plus 6 minus 3x is equal to 14 plus 2. 6 plus 6 is 12 minus 6x equals 14 plus 2. I'm sorry, that's an x right here. All right, plus 6x plus 6x, I get 12 is equal to 20x plus 2 minus 2 minus 2, 10 is equal to 20x, divide by 20, and x is equal to 1/2, okay? If I plug it into PR, since it's 1/2, that would be 14 times 1/2, which is 7, plus 2 is 9, okay? So PR is equal to 9. All right, and last problem over here. It says point C is the midpoint of BD. Find the length of BC. Notice the difference here. They're telling me that they're congruent. I don't know the length of BD, so I can't do my part plus part equals whole. But I do know that if these are congruent, then their measures are the same. So I'm just going to set them equal to each other. 3x minus 2 is equal to 2x plus 3. That is also another true statement. Minus 2x minus 2x, x minus 2 is equal to 3, plus 2 plus 2, x is equal to 5. Okay, if I find the length of BC, it technically wouldn't matter which one you plugged it into. So BC would be equal to 3 times 5 minus 2 would be 15 minus 2. So BC is equal to 13. Okay.